Hello, and today we're going to do homework 7.2 involving multiplying and dividing rational expressions. Now in 7.1, if you'll remember in 7.1, all we had was one big fraction, one big rational expression. We didn't do any multiplying or dividing. We were given one big expression and we tried to simplify it. You know, you factor the top, you factor the bottoms, and if you see something that's the same top and bottom, you would cancel out those factors. Now here we have actually two fractions that are being multiplied. Two fractions. See the symbol right there? We have to have two fractions. And so, got to remember how to multiply fractions. Just what's true with numbers would be true with expressions that have variables. So if I were to give you, I'm going to give you a little lecture on multiplying and dividing with numbers. So if I gave you 1/2 times 4/7, what would you do? Well, think back. What you would do is you multiply the numerators, you multiply the tops. 1 times 4 is 4. Divided by 2 times 7 is 14, which is the correct answer, but no computer will ever accept this. No instructor would ever accept this because that fraction can be simplified. You always have to be simplifying your fractions. And it looks like they're even numbers, so I can certainly divide top and bottom by 2. So if I divide top and bottom by 2, I get 2. 2 goes into 14 7 times, and that's the answer to the original problem. Now, I could have got this 2/7 a lot faster by just noticing. Start with the original problem here. I see 2 here on the bottom, 4 on the top. How about if I divide the top and bottom of those numbers by 2? Okay, and then you get the answer right quickly. 1 times 2 is 2. 1 times 7 is 7. So that's something that you should keep in the back of your mind. Sometimes you just multiply the tops, you multiply the bottoms, you get an expression that has big numbers that might need to be simplified. But if you start off with your fractions, if you notice that those original fractions, top and bottom, have numbers that go into them, might as well just divide those numbers into them and start off, and then you'll end up with smaller numbers. 4 became a 2. 2 became a 1. Then do your multiplying the tops and multiplying the bottoms. Now, how do you divide? Let's take 3/8 divided by. Oh, that's not divided by. Edit, undo. Okay. And that 8 even looks pretty bad too. So let's undo everything. Edit, undo. Okay, let's make a better looking 8. Okay, that's a nice 8 right there. Divided by 2/7. Okay, interesting problem. Now you remember how to divide by, when you have fractions, what you need to do to divide? Well, division we cannot do. You know what you need to do? You need to transform this into a multiplication. So basically, knowing multiplication also involves multiplying, doing division. And what you need to do is change that to a multiplication by doing this. Keep the first fraction. Keep the first fraction. And then multiply by what's called the reciprocal of the second fraction. The reciprocal is you flip the fraction around. 7, 2. And then you multiply the tops, multiply the bottoms the same way we did before. Now, let's see, is there a way we can maybe simplify this? See, top and bottom. Don't start canceling on the same level. Don't cancel. Don't say 2 goes into 8 4 times. They have to be on different levels, top and bottom. So I can't see any number that divides into 3 and 7 using the numbers in the below. So why don't we just say 3 times 7 is 21. Divided by 8 times 2 is 16. And there's your theory of what you need to do in this chapter. Now, when you get variables involved, it gets kind of complicated, a little bit more complicated, nothing major. So let's see how we do this one. Okay, don't save that. Let's start off nice and fresh. File, new. Okay. Move this over. Okay, 2z cubed divided by 3z to the 5th times 2z to the 6th is equal to, that's a ugly looking 2, best I can do with the mouse. You know, I can't, it doesn't seem like I can do much with the numbers, so I'm just going to multiply the tops. Get ready, make a big fraction there. 2 times 2 is 4, and don't forget z cubed. Multiply the bottoms. 3. And then you got 5 z's on the bottom, and then another 6 z's on the bottom. You've got 11 z's on the bottom. You add the exponents when they're on the same level. So now we've made it one fraction, but don't accept that, because that's not going to give you a green box, because you've got z's on the top and z's on the bottom. So remember what you're going to do. You're bottom heavy on z's, so 3 of these cancels out 3 of these, leaves you with 8. So it looks to me like the answer would be, make a fraction, put a 4 there, and it looks like it would be 3z, and raise that to the 8th power. Check your answer, and so far we got one good one, so we're multiplying. I am going to skip that one because I'm going to go ahead and do this. Well, let's not skip that one. I thought we'd have another one of those type of problems, so I'll do this one. Okay, first off, the negative means nothing. Okay, the end answer is going to be negative. When I write this out, I like to put the negatives up top. So I'm going to say negative 3 x squared y divided by 2 times 10 over x cubed y equals. Well, you know what? Remember I told you, look at the numbers. Look at the numbers. See, this is 2 on the bottom, 10 on the top. So why don't we start canceling? Divide the bottom by 2, 1. Divide the top by 2, you get 5. So the numbers end up being a little bit simpler. Let's multiply the tops with smaller numbers. Negative 3 times 5 is negative 15. X squared and y. The bottom is 1 times x cubed and y. And this looks like the same stuff I think we may have done in the section 7.1, and I know you did this in Algebra 1 as well. So what you're going to do is say, well, the y certainly cancel. You've got a y on top, y on the bottom. They cancel, see. And then you're bottom heavy on x's, so 2 of those cancels out 2 of those, it leaves you with 1x. So it looks to me like what survived was a negative 15 x. Check your answer. Yay, we got that one right. See? You can do math. Okay, so now what do we do here? So let's clear this out. Don't save. Let's do file, new. Okay. Move this over. You know what we're going to do? Here's what we're going to do. We're going to say y to the 4th. Copy the problem. Whenever you see a plus, what do pluses do? Pluses and minuses, they bind terms together as one big unit. So I'm going to put the parentheses around the entire unit. Times 9 y plus 45. And that's a unit too. That's a bundle. Divided by y to the 7th. Here's what you're going to do. You multiply the tops, you multiply the bottoms. You know how you multiply the tops and bottoms? Here's what you do. Okay? Rather than copy that problem again, pretend this was one straight, beautiful division sign. The top is simply those two things multiplied. They may be far away, but they're still multiplied. Those two guys are multiplied even though the terms are far away. So what do we do now? Well, certainly the y's can cancel because they're the same base, but I like to save the best for last. What I like to do is go through and factor everything that we can possibly factor before I actually start dividing things. So what I'm going to do is make a division, and then I'm going to say y to the 4th. What we can do here is pull out a 9. 9. And then what we got here, when we pull out a 9, we get y plus 5. Okay, and then the bottom is one bundle. Not much you can do there. Just copy it. And then we have y to the 7th. Now comes the fun part. Bang, bang, that bundle goes away. It's the same thing top and bottom. I'm bottom heavy on y's, so 4 of those cancels out 4 of these, leaves you with 3. And what survived is 9 up top, y cubed on the bottom. Let's see if that looks right. Okay, 9 up top, y cubed on the bottom. That's what it looks like to me. After you got to be careful with all the crossouts that you don't miss it. Okay, that looks good to me. Let's not second guess this. Very good. Very, very good. Okay. So, next question. Next question looks like it might be a problem. So let's go ahead and do a new, don't save, file, new. Okay. Move this over here. You know what I'm going to do? Here's what I'm going to do to try to speed this up, because there's no sense having to copy all this on this. Realistically, what I would do is put parentheses around all these bundles. Pretend you saw parentheses, because that's what pluses and minuses do. And then what I would do is multiply the tops and multiply the bottoms and just extend this division right along the line. So I'm going to do that right here. There's my big division. What I have up top is 3x minus 9 times 4x plus 12. Now, I didn't factor anything at this point. I just wanted to show you the end result of multiplying the tops and multiplying the bottoms. 5x plus 15. And then we've got 10x minus 30. Okay. Do you see anything that's the same top and bottom? I don't see any factors that are the same top and bottom. So what do we need to do? Well, we need to factor everything you can possibly factor. That's what you need to do. Factor everything that you can possibly factor. So up here, we'll make a division sign. I'm going to look at this guy right over here, and I see that I can pull out a 3. X minus 3. Those are my factors. Over here, this guy, I can pull out a 4. X plus 3. Okay, this guy over here, I can pull out a 5. See, now things are starting to look like we can start canceling, but I saved the best for last. Pull the 10 out. I got x minus 3 right there. Now we can have some fun. Okay, the x minus 3 terms go away. Bye. X plus 3 terms go away. Bye. See, this big mess ends up being a bunch of numbers. 12, 12, 3 times 4 is 12, over 50. And that won't be the answer. What will be the answer is if I divide top and bottom by 2, which is 6 over 25. Okay, which I could have got immediately because 4 over 10, I could have divided the top by 2, leaving you with 2, the bottom by 2, leaving you with 5. So you got 3 times 2 is 6, 5 times 5 is 25. Who would have thunk it that, come on, right there, put that in there, that this big mess ends up being 6 over 25. I wouldn't have thought it until you do the math. There you go. Okay, let's see what the next one is. Oh my God, that's an intense one. Let me just see what the next one is. Okay, that's a hard one. They're both pretty much the same. Okay, I'm going to do number 6. I'm going to leave you with one hard one to do. Okay, so let's clear this out. Let's go ahead and say, let's close this up, because it looks like a lot of work. File, new, okay, and let me show you something here. This is going to be one bundle here, one bundle there, bundle here. We basically got 4 bundles. And so why don't we do this? Those bundles are going to need to be factored anyway. So what I'm going to do is on the top of this fraction, the top left, this is the top left, I'm going to go ahead and take that and factor it, because you're going to need to do that anyway. And so here's what we got for our factors. X, X, and it looks like plus and minus, and it looks like it would be 6 and 2. 6 and 2 would do the job for that guy. 6 and 2. Okay. Top right. Top right. Don't forget the simple stuff. Now the top right, that's a bundle in itself. What I'm going to do is simply pull out a 5x. And what's left over is, if I pull out a 5 from 10, I'm left with 2. The x goes away. Plus, if I pull out 5 from 5 is 1. I had 2 x's. I pulled one out. I got 2 plus x. Looks kind of strange, but go with me. Accept it. X plus 2 is x plus 2. The bottom guy is x plus 2 over here. The bottom guy there. And now this guy looks to me like I can't pull anything out. This guy here is a bundle. And that bundle, I cannot factor anything out. I think I need a magic number for this. So, so off to the side here on the bottom here, I'm going to say pull the 5 away from the x squared. I'm going to have x squared plus 12x. And then 5 times 4 is 20. I'm going to have to magic number that guy. And then what I'm going to need to do is factor that to be x plus x plus, I think 10 and 2. 10 and 2 would do the job for 10 times 2 is 20, and they would add to be 12. But that's not enough, because now what we need to do is divide, make fractions out of those numbers, simplify the fractions. So this is going to be x plus 2. And 2/5 is simplified as much as you can. So what you need, if you still have a fraction after you simplify it, put the 5, the denominator, in front of the x, and you're good to go. Now let's transfer this up here. X plus 2. And what else we have? We have x plus 2 and 5x plus 2. 5x plus 2. Okay, the worst is over. Now let's make a bigger division sign. Okay, the worst is over. What I see here is x plus 2, but you know 2 plus x is the same thing? When you have addition, it doesn't matter whether you put the x in front or the x in back. It's just cooler, better looking to have the x in front. 3 plus 5 is the same thing as 5 plus 3. So let's cancel those two. Those are exactly the same. These two guys happen to be exactly the same. And you know what? I don't see anything else I can cancel. 5x plus 2 bundle is what it is. And you know you can't cancel the 5x inside that bundle. So I'm going to go with this. Whatever's left over is going to be your answer. So let me push this over here and say whatever's left over, we basically have a fraction. I'm going to say x minus 6, 5x. You don't need to multiply it through. Don't need to multiply it through. Leave it like that. And then on the bottom is 5x plus 2. No need for the parentheses, because that bundle isn't being multiplied, isn't multiplying anything. And we got it right. There you go. Yay. Now, the next half of this test, of this thing, is division. And you know, basically division is the same thing as multiplication. Okay? Division is the same thing as multiplication. Okay, so let's, this might be too easy, this problem here. So I'm going to skip that one. I'm going to go to a harder problem. That might be too easy. Okay, I'll do number 8. Here's what I'm going to do. I'm not going to waste my effort copying this. Okay, because what I'm going to do is make a multiplication. 14 over x to the 7th. Keep the first fraction. Change it to a multiplication. Flip the second fraction, reciprocal. 3x cubed and 2. Now, isn't that the same thing we just did? It's exactly the same thing as what we just did. In fact, what I'm going to do is I notice 14 and 2. I can divide top and bottom by 2, giving you these numbers here. And then I'm going to just go ahead and do the multiplication. 21 x cubed divided by x to the 7th. And you know that 3 of these will cancel out 3 of these, leaving you with 4. And so I'm hoping that the answer is 21 up top, x to the 4th on the bottom. Great stuff. Great stuff being done here. This is I'm going to let you do that one. That's the same thing. I want to start doing some factoring. I'm going to do some factoring. And let's do some factoring here. Here's what I'm going to do. File, new. Okay. Here's what I'm going to do. I'm going to show you how to do this a lot quicker to save yourself a little bit of time. I'm going to get my division symbol there. These are bundles. Okay, I got 4 bundles. What I'm going to do is show basically I'm going to factor each bundle while I'm doing the problem. So basically what's going to happen is this fraction doesn't change its position. So when I pull out 6 from 6a minus 12, I get a minus 2. Okay. Now this guy here is a bundle that I'm going to pull out an 8 from. And that's a plus 4. Okay, so I took care of the first left side of the fraction. Now this guy here, you know that when you divide, you're going to have to flip the second fraction. So this 7a plus 28 bundle would be on the top. So what I'm going to do is factor that 7a plus 28 and put the answer on the top. That's a plus 4. 7 times a plus 4. And then on the bottom, I would put this bundle's factor job down here. 33, a minus 2. Now you get to have some fun by killing off the a plus 4 top and bottom, a minus 2 top and bottom. And it looks to me like, what do we got here? Well, I would say 42 times one big mother number there, so we shouldn't have to do that. 6 over 8. I can divide top and bottom by 2. That would be 3 over 4. Okay? That takes care of that guy. Oh, look at this. 3 up top, 33 on the bottom. Can't I divide top and bottom by 3? 11. So it looks like what we have for an answer for that problem is 7 over 44. 4 times 11. Let's see if that's right. 4 over 11. Oh, what am I talking about? Geez, I'm losing my mind. 4 over 11. 7 over 44. Check your answer. There you go. Only 5 more problems to do. Okay, so let's take a look at this one. I think I can, using this little technique I'm showing you here, okay, I can save ourselves a little bit of paper. Here's my division symbol. The left fraction doesn't change, but I will make a bundle out of that v plus 7. 91 on the bottom. Times 13 goes up top. Now what the bottom is a bundle that needs to be factored. That's a difference of two squares. Looks to me like we have 7 plus v, 7 minus v. Remember, you have to flip the second fraction. There's your bundles. Does anything cancel? Remember, v plus 7 is the same thing as 7 plus v. Same exact thing. It just doesn't look right because we're used to having our variables in front, but they're the same. Something is mysterious with the 13 and 91. 13. I bet you 13 goes into 91. I think it goes in 7 times. Yeah, so I can cancel. Divide top and bottom by 13. 13 goes into 13 once. Goes into 7 times. Okay, so so here's my answer. Here's my answer. Let's take a look at my chicken scratch there. Everything is ultimately a fraction. I canceled everything up top, leaves you with a 1 up top. 7 times this bundle. No need to multiply through. 7 bundle. 7 minus v. 7 minus v. Close it. Let's see if that's right. Good job. Great job. Excellent job. Just 4 more. Just 4 more of these things. Okay, so let's see how this works out. Now, we need some new paper. Need some new canvas. Don't save that. File, new. Okay. Let's go ahead and start developing. Ultimately, we have a fraction. Okay. This first fraction, the left side of this fraction, it stays the same. What I'm going to have is that's a bundle that needs to be factored, and that would be y plus 1, y minus 1. The bottom is y minus 1. A 1 minus y, I'm sorry. It is what it is. There's nothing you can do there. I didn't factor anything. I just copied it. Times the bottom, which is y, goes up top. This bundle y plus 1 goes on the bottom. In fact, there was no factoring there. I just flipped the second fraction. So what do you got going on here? What do we got? Well, y plus 1, goodbye. Do you remember this? 1 minus y, y minus 1. They almost look the same. But do you remember what we called those? Here we have y, negative y. Negative 1, 1. Everything on the top of this term is the same thing as the other one, only opposite. I can cancel those two, leaving a minus 1 in its place. Put it on the top someplace. So, what do we got? I guess the bottom is the number 1. This is negative y over 1. Don't do over 1. I think they'll even mark that wrong. Negative y over 1. Okay? I think they'll even mark that wrong. I don't want to see that red box. Anything divided by 1 is just the top. So just say minus y. Check your answer. There you go. There you go. So, wow, that's a double variable problem, but they're really masochists here. Okay, okay, we'll do 2 more. 2 more problems, and then you're good to go with this section here. That looks like I'm going to take a lot of time there. So let's go here, File, New. Okay, move this over here. All right, here's what I'm going to do. Make a division. That's a bundle. What I'm doing is I'm taking those bundles, and at the same time, I'm don't waste. I'm not going to waste time copying these things. I'm going to factor them because you know that's what you have to do. Excuse me. Let's see what we got here. Well, all I can do is pull out an x and a y. That's all I can do is an x and a y from that. So if I pull out an x and a y from this, I'm left with an x. Remember, when you multiply through, you'll get the original term. Plus, I'm not doing anything with numbers. You're left with 5. 5. That's an ugly 5, but just a 5. And I think I pulled out the x, and I pulled out 1y. It looks like 5y. Right there. Right there. Now the bottom is a bundle. That's a difference of 2 squares. And see, I like difference of 2 squares because they're easy to factor. 5y. See, x is being squared, 5y is being squared. One's positive, one's negative. Now, resist the temptation of trying to cancel those. I like to save the best for last. Divided by. This top goes on the bottom, so this is going to be 2x squared y. The bottom looks like a double variable problem. And a double variable problem basically means you forget the second variable. And you forget the second variable, you'll have x squared minus 6x plus 5. Factoring that, I get x and x squared minus 6x plus 5. And that means a double negative for the plus 5, negative in the middle, 5 and 1. And then we have to tack on the y to get the 5y squared. There you go. And remember, that's that 1y minus 1y is really minus y. Okay, what do we got going on here? Let's see what cancels. Okay, it certainly just cancels right here. That cancels. X minus 5y cancels. That's good. That goes away. Oh boy, we're canceling a lot. Let's see. This y cancels, and this x cancels. Let's smush it out. That x cancels out this, and I think we're good to go. So after all said and done, what's left over on the top is x minus y. It's not really multiplying anything. Divided by 2x. Divided by 2x. Look at that. That big mess is equal to that, huh? I hope it is. X minus y divided by 2x. Check your answer. Yes. Yes, yes, yes. I'm so happy. I'm still amazed that this stuff works. Everything that I learned from way back when still applies and still functions and still works. And the last one we're going to do is number 14. This looks like an intense one because after you do number 14, they give you this thing on number 15, which is a nut thing. The answer is negative. Okay, and then you can do the actual cross out for that. So you can do this. Here's what I'm going to do. I'm going to get myself ready. You got yourself 4 factor jobs here. So I'm going to go ahead and do this, 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 and this. First fraction doesn't change. I'm looking at this first guy. X, double negatives. 9 and 5. 9 and 5. Now the bottom one doesn't change, basically stays where it is. The factor jobs, that is, stays where they say, where they are. And this is x and x. Looks like plus and minus there too. 8 and 9 and 8. 9 and 8. 9 and 8. Okay. That's good. That's good. Now this big bundle over here, I'm going to factor and put the answer on the bottom because you need to flip the second fraction. So I'm looking at the top and I'm putting the answer on the bottom. We got x and x and x and x. I'm looking at this guy, plus and minus. Looks like 5 and 2. 5 and 2 would do the nice job there. Now the bottom over here, I factor and put the factors on top. X and x, minus 9 and plus 2. Yep, that's it. Minus 18 and 7. The worst is over. Now the fun begins. The fun begins where we start canceling stuff. X minus 5, goodbye. X plus 2 is top and bottom. X minus 9, top and bottom. What's left over is the answer. And this is the answer right over here. Okay. In fact, I don't need the parentheses because that bundle isn't multiplying anything. No need to put the parentheses. And then we have x plus 8. Check your answer, and that's it. That's it. So next thing we're going to do is section 7.3. And I'm going to prepare you for section 7.3 right now. Section 7.3 happens to be the hardest section in the math algebra 2. So it involves adding and subtracting. Okay, and we'll leave it at that. Well, after we're done with section 7.3, it gets easier. It gets easier. The rest of the course becomes easier. But get ready. Have a good night's sleep before you start section 7.3. Okay, take care. Bye.